Okay, so force and weight, this is the difference between the force and weight. Force and weight. Suppose if we take a simple model, suppose mass, object mass is mass equal to 10 kg, acceleration equal to 5 meter per second square. So that force equal to, we know that mass m denoted by m into acceleration, let us say that a. So that therefore mass equal to 10 kg into acceleration of 5 meter per second square. So therefore this is equal to 50 kg meter per second square, otherwise this is equal to 50 newtons. 50 newtons. So here there are the three terms are there. F is equal to m into a, force equal to mass into acceleration. In this, the three terms are there in this equation. If we get two terms, we can calculate the third one. If you know if you know mass and acceleration, we can calculate force. If you know from this equation, we can write mass equal to force by acceleration, or acceleration equal to force by mass. Like this, we can do some. We can learn some mathematical problems, and we can solve by using the relationship. So this is about force and weight. Next, coming to that next property, mass density of fluid equal to definition of mass divided by unit volume. This units equal to mass kg, volume meter cube. Okay, so therefore units equal to kg by meter cube. So what we can understand here from the definition, suppose you take 1 meter cube of volume. Let us say that you take this container like this. Let us assume this is the length equal to 1 meter, width equal to 1 meter, depth equal to 1 meter, length equal to 1 meter, width equal to 1 meter. What is the volume of this container? 1 meter into volume equal to V equal to 1 meter into 1 meter into 1 meter. This is equal to 1 meter cube. This is the volume. So what is the meaning of that mass density equal to mass by unit volume? 1 meter cube, 1 unit. 1 unit means 1 meter cube. In 1 meter cube, whatever quantity of that fluid is accommodated, that accommodated fluid mass divided by that 1 meter cube volume. That is the meaning of that mass density. I hope you can understand. So whatever the quantity, volume of fluid accommodated in that 1 meter cube volume, its mass, that's mass divided by that volume gives the mass density. Okay, from this mass density denoted by rho, mass m denoted by m, volume v. Volume v. So from this equation, there are three terms. Obviously, if you know the two terms value, third term we can calculate. Suppose for example, mass equal to, from this, suppose if you want to calculate mass equal to rho v, or otherwise volume equal to rho by mass by rho. So like this we can use these relations. We can find out the whatever unknown parameter is there. If you know two parameters, third parameter we can calculate. Suppose you take one model. Suppose mass equal to 10 kgs, 1000 kgs, volume equal to 1 meter cube, and then mass density equal to formula mass by unit volume, so that 1000 divided by kgs, volume 1 meter cube. So therefore this is equal to 1000 kg per meter cube. So what we can understand from this answer? So in 1 meter cube of volume, 1000 kgs of fluid can be accommodated. That is the meaning. In 1 meter cube, 1000 kgs of weight, 1000 kgs mass of fluid can be accommodated. That is the meaning. So here, of course, suppose in case the volume equal to, let us say that volume equal to 10 meter cube. In this case, suppose they find out the mass density. Simple thing is the same thing. So here volume equal to 10 meter cube. So therefore you cancel this one. They get cancelled. So that this is equal to 100 kg per meter cube. So here in this case, what we can understand here, in 1 meter cube of volume, that fluid 100 kg mass can be accommodated. That is the meaning. So that here like this we can find out if you know the mass density. If you know mass density is already I have given density. If you know the mass density and mass, we can calculate the volume. If you want the mass, if you know the density and volume, by multiplying these things, we can get the mass. Like this, if you know two terms, third term can be calculated. Those things are arrived from this equation. Weight density. Weight density equal to weight of fluid divided by unit volume. Again the units equal to, here weight equal to measured in newtons and volume equal to meter cube. So this is equal to units Newton per meter cube. So I can write in another way. So weight equal to weight density equal to, I can write another way, mass density into acceleration due to gravity. Weight density equal to acceleration due to gravity, g. So how we can arrive this form, mass density into g? So weight equal to, here the weight equal to mass into acceleration due to gravity. So mass into, I can write here, is equal to weight equal to mass into acceleration due to gravity, that is divided by volume. So you take it this one, we know that mass by volume equal to mass density, so that is equal to, this is the mass density into g, acceleration due to gravity. So in this case, units you will get mass kgs, volume meter cube, g meter per second square, kg meter per second square equal to Newton. So therefore Newton divided by meter cube, kg meter per second square equal to 1 Newton. So therefore that is equal to 1 Newton. So that therefore Newton divided by meter cube. We can write like this also. If you take one model, suppose weight equal to 1000 newtons, volume equal to and volume equal to 10 meter cube. Find out weight density. So weight density equal to weight by volume. So I don't want to write again the formula. Weight equal to 1000 newtons divided by volume is 10 meter cube. So this is equal to, they get cancelled, 0 so that is 100 Newton per meter cube. So what we can understand here, so density is expressed per 1 meter cube unit volume. In 1 unit volume, what is the quantity of weight fluid that can be accommodated, that is the meaning. So here in 1 meter cube 100 newtons weight of fluid can be accommodated, as usual. So you know that here, for example, weight density, volume is there, weight is there. From this, suppose if you want to find out, they are asked mass density. From this mass density equal to from this equation, mass density equal to weight density divided by g. So weight density equal to mass density into g. Already we learned in the previous step, so that mass density equal to weight density by g. So therefore weight density equal to 100 Newton per meter cube divided by g. That is equal to 9.81 meter per second square. So in this case, this is equal to 10.19 10.19. What is this? You see here, this is the meter cube per second. This is the Newton per meter cube. Newton per meter cube. Otherwise, this is equal to mass density. Mass density. What is the units? Kg per meter cube. Kg per meter cube. So that we have to arrive from this units kg per meter cube. Kg per meter cube. If you see that, I can erase this one. If you see that, that is equal to mass density equal to density equal to 10.19. What is that? Newton per meter cube into second square per meter. Yes, second square per meter. But the thing is that 1 Newton, we know that 1 Newton equal to 1 kg meter per second square. That we have to substitute here. Kg meter per second square divided by meter cube into second square divided by meter. So therefore they will get cancelled. This is equal to, we can write like this. This is equal to kg meter into kg meter into divided by second square into meter cube into second square meter. If you simplify this one, so that they can get cancelled. Second meter cancelled. Finally, you can get kg per meter cube. Like this, we have to arrive. So that this mass density equal to 10.19 kg per meter cube. That is the final. Like this, you have to convert the units. So we can understand here in weight density. Suppose they will ask, of course. So from here, what is the mass? What is the mass of that fluid? That is nothing but 10.19 kg. 10.19 kg mass. In this mass density, what is the mass? What is the mass of that fluid equal to 10.19 kg. Okay. Like this, we can do different types of problems. In this mass density, weight density from, if you know the weight density, weight density and weight of fluid, we can calculate volume. Calculate volume. At the same time, if you know these three terms, we can calculate the mass density. We can calculate mass. All these things we can calculate. But we have to careful at conversion of the units. Volume equal to, take it simple calculation, 1000. Volume equal to 20, otherwise 5 meter cube. Find out mass density. density, weight, density, weight density, weight. Okay, so these things we can calculate. First we have to find out there is a mass and a volume. We can find out the mass density. Mass density equal to mass by volume. We know that this is the mass volume. So mass equal to 1000 kg divided by volume equal to 5 meter cube. So mass density or weight density, it is a calculate for 1 meter cube. 1 meter cube. So therefore this is a get cancelled 500. So this is equal to 500 kg per meter cube. 500 kg per meter cube. Okay. So 500 kg per meter cube. So therefore from here weight density equal to weight density equal to formula weight by volume or mass density weight by volume or mass density divided by mass density into acceleration due to gravity. Mass density into acceleration due to gravity. Am I right? Yes, right. We can calculate this one. Mass density equal to 500 kg per meter cube. So that simply you can multiply it. You can find out weight also, or otherwise you can find out weight density. Weight density by using the mass density. I can use this equation. I can use that equation. So that is equal to mass density equal to 500. I can arrange this one. Weight density equal to so mass density into acceleration due to gravity, that is equal to 500 kg per meter cube into acceleration due to gravity 9.81 meter per second square is equal to 500 into 9.81, that is equal to 4905 kg per meter cube into meter per second square. So kg meter per second square is equal to Newton. So therefore this is equal to 4900 Newton per meter cube. Okay. So meter cube. Okay. Now that weight equal to what is the formula here? Weight from this weight density equal to weight density into volume. Density, I can write. Weight equal to weight density into volume. Weight density equal to how much? 9500 Newton per meter cube into volume 5 meter cube. 5 meter cube. Okay, if you five meter cube, this is into 5, 24,500 to 5. It is newtons. There are newtons. So because these get cancelled, so that this is equal to newtons. That is equal to newtons. Newtons. Okay, this is enough. No need to go for this one. This step. Weight equal to newtons. If you observe this one, weight density equal to 4905 Newton per meter cube. Weight density equal to. But what we are going to calculate weight? Weight means what is the weight of the material that can accommodated in 5 meter cube? That you have to understand. What is the weight of the material that can be accommodated in 5 meter cube? That is the weight. That is the weight. From that 1 meter cube 4905 newtons can be accommodated. Then in 5 meter cube how much? That is the equation, simple equation. So you simply multiply that one, you can get this much of newtons, this much of newtons. So that from this we can calculate anything, anything, whatever you want. If you know that relations, so weight density, mass density, you can calculate volume, weight density, mass, weight, all these things we can calculate.